I'm Sonali Kelkar from City International School, and today we are going to do activities based on the chapter Metals and Non-Metals. Other than that, we are going to do important questions, 3 marker, 5 markers and MCQs. So let's start with the first activity. This is activity 3.9, and where what you are supposed to do, where you have to burn the metal and you have to observe the flame, and on the basis of that flame, on the basis of the color of the flame, you have to identify which metal burns with which kind of flame, right? So observation, what you have to see that not all metal burns easily. Copper and aluminium takes time to burn. Flame color, sodium, color of the sodium is yellow, and magnesium, color of the flame of magnesium is white. Aluminium flame color is silver, white, and copper is blue flame. Okay, here you can see the copper is blue flame and sodium is yellowish in color. Magnesium, I haven't seen magnesium, I haven't shown magnesium over here. Regarding the solubility, so when you burn metals, what happens? When you burn metal oxides are formed, right? And whether these metal oxides are soluble in water or not, that we have to find out. So metal oxides forms metal hydroxide with water. So when you mix metal oxide with water, metal hydroxide is going to form. So they are soluble in water, but beryllium and magnesium are exceptions as they are slightly soluble in water. So when you mix metal oxide in water, metal hydroxides are formed. Now what about the nature of metal hydroxide, children? So when you mix metal hydroxide in water, and when you bring red litmus paper, you will find there is a change in the lead litmus paper. It will turn blue. So this shows that metal oxide are basic in nature. So metal are highly reactive elements. They react with oxygen radially to form metal oxide. Highly reactive metals like lithium, sodium, potassium, beryllium, magnesium react spontaneously. In fact, sodium and potassium react very fast. The other metals like aluminum, copper takes time to burn. It produces a specific flame color. Then many times flame color is used to find the constituent of the substance, right? Here we can see the equation where copper burn in presence of oxygen, copper oxide is formed. So what is the conclusion of this activity? Metals on heating burn to produce their oxides. During this process they produce characteristic flame. So this was the aim of the activity. So by burning the metal, you have to find the color of the flame, and with the color of the flame you have to identify the metal. Exception in case of metal oxide. Certain metal oxides, they show both acidic and basic reactions, right? Acidic property and basic property. So these type of metal oxide are known as amphoteric metal oxide. So what are the example of amphoteric metals? The example of amphoteric metals are aluminium, aluminum oxide, okay, and zinc oxide. I'll just write the Z and O. Aluminium oxide, Al2O3, as well as lead oxide. Lead oxide is not given in your book, but lead oxide, all the three oxides, they are amphoteric in nature. That means they show both acidic as well as basic behavior. Let's take the next activity. Right, over here we are going to react all the metals with water. Let's start with the first metal. Let's take potassium and sodium and calcium. Okay, we will going to react all these three metals with cold water, and we will see the reaction. potassium and sodium and calcium, definitely they are going to find hydroxides of that particular metal, and hydrogen gas is released. In all the three cases, hydrogen gas is released. But in case of sodium and potassium, this reaction is highly vigorous reaction. Why this reaction is vigorous reaction? Because when sodium and potassium react with water, a lot of heat is produced. So this is exothermic reaction. Exothermic reaction. So this heat is capable of this exothermic reaction. This heat is capable of burning hydrogen. The hydrogen will burn in presence of oxygen, and you will find that the metal starts burning. Okay, and similar case with sodium also, and we will see that sodium hydroxide and potassium hydroxide is formed. In case of calcium, calcium reacts with cold water. Okay, here reaction with hot water, but calcium react less with cold water, but it do react with cold water. Okay, and when calcium react with cold water, calcium hydroxide is formed and hydrogen gas is released. In this case, you will find that calcium starts floating because the bubbles of hydrogen gas formed, it stick to the calcium and it will bring the calcium on the surface, right? This reaction is a less vigorous reaction, so it won't make hydrogen to catch fire. So you will, it is, though it is an exothermic reaction, but it is not as vigorous as the above two reactions. But you will find that calcium's particles are floating on the top, on the surface, right? Why? Because it gets stick to the hydrogen bubbles. Very important question that can be asked in exam. Then reaction with the hot water. Okay, here they have taken hot steam, but there is one more reaction with hot water. Magnesium do not react with cold water, it reacts with hot water. So in a whole series of metal, magnesium reacts with hot water. So I'll write over here hot water. Magnesium hydroxide will be formed and hydrogen gas will be released. Okay, magnesium hydroxide will be formed and hydrogen gas will be released. I'll just write a reaction over here. Mg plus H2O gives you Mg OH whole twice plus hydrogen is released, right? You need to balance the equation. Hydrogen 2 plus 2 4, oxygen is 2, so I'll put 2 over here. My hydrogen got balance, my oxygen got balance, right? And everything got balance. Here this type of reaction is given in your NCERT, whereas if you search in Wikipedia, magnesium react with the magnesium do react with water and produce magnesium oxide, and hydrogen gas is released. That reaction is also given, but in NCERT this reaction is given, so we are supposed to write only this reaction. Now coming to the other metals such as iron, zinc, aluminium. Okay, so aluminium, zinc, iron, we will go according to the activity series. Aluminium, zinc and iron, right? These metals will react with steam. Metals will react with steam and they will form oxides, right? They will form oxides. Okay, aluminium oxide and hydrogen gas will be released. Here, over here, they have written aluminium hydroxide, but in your book, they have written aluminium oxide. So I'll just cut it and I'll write Al2O3, aluminium oxide is formed and hydrogen gas is released, and we need to balance the equation. 3 here and 2 over here it's given. Water, I'm supposed to write here 3. I'll just write 3H2O, right? So 6 hydrogen, 2 aluminum, 2 aluminum. Yes, oxygen is 3 and oxygen is 3, so balance, this equation is balanced. So aluminum, zinc and iron will react with steam, and rest of the metals, that is Pb, then copper, mercury, Ag, silver, Au, Ag and Au, and Pt, platinum. All these metals won't show any reaction with water. Okay, so metals such as lead, copper, silver, gold do not react with water at all. So this you have to keep in mind. And inference, the metal react with water and forms metal hydroxide. It produces hydrogen gas, which we can check by placing a matchstick near to it. Yeah, this is a summary of the activity that we did in the last slide. So you just pause it and write down these summary. It's very important and easy way to learn. Now coming to the next activity, here the metals are going to react with the dilute hydrochloric acid. You either take dilute hydrochloric acid or you can take dilute H2SO4, right? In this activity they have taken dilute hydrochloric acid in the NCERT book, and we will find that metal sodium and potassium, this will show a explosion, okay, a very explosive reaction with acids. Whereas if you go down the series, calcium, then magnesium, aluminum, zinc, calcium is most reactive, very fast reactive, aluminum, zinc moderate, iron and lead slow, and you won't find any reaction with copper, mercury, silver and gold. Okay, so all these metals won't show any reaction with dilute H2SO4 or dilute HCl. Right, here I want to tell you one thing. Why don't we take a dilute HNO3? Because H2NO3, HNO3, nitric acid, is a strong oxidizing agent, so it reduces hydrogen. So we know that the hydrogen gas is produced in the reaction, and because this is a oxidizing agent, so definitely it will going to oxidize hydrogen. What will happen when hydrogen get oxidized? When hydrogen get oxidized, it immediately changes into water, right? So that is why we don't take HNO3, because it's a strong oxidizing agent. It oxidizes the hydrogen, produces water, and itself get reduced to any of the nitrogen oxide, NO2, any of the nitrogen oxide, that is N2O or NO2, right? N2O or NO2. So that is why we don't take dilute HNO3. But here also there is an exception, and the exception is magnesium Mg and manganese Mn react with very dilute HNO3 to evolve H2 hydrogen gas. Magnesium Mg and manganese, these react with a very dilute, this very dilute is very important word, okay, dilute HNO3, nitric acid. So this you have to remember. This is a very important point on this particular reaction, right? Here you can see the metals calcium, how reacts with HCl, aqueous or dilute HCl. So calcium chloride is formed and hydrogen gas is released, and this is the order of the reactivity series of metal with acids. Here you can also start with magnesium, aluminum, zinc, and Pb and Cu, right? If I tell you that Cu react with the H2 SO4 dilute. Okay, this is a dilute H2SO4. CuSO4 form and H2 is released. Okay, is this statement is true? Is it true or false? If it is false, why it is false? Because the element copper, silver, gold and copper, silver, gold, all these metals do not react with acid. Copper, mercury, silver, gold, they do not react with the acid, dilute H2SO4 or dilute HCl. That is why this statement is absolutely wrong. Activity 3.12, we are asked to dip a copper and iron nail into a salt solution of another metal and observe the reaction. Okay, this activity is a quite familiar activity. You have been doing this activity since in your junior classes also you have done. So let's see what is the reaction, how it takes place. So what you are going to observe, we will observe that more reactive metals displace with the metals from other salt solution, okay, and forms a corresponding salt. So more reactive metals displace metals from the other salt solution and forms corresponding salt. So instead of here we can write iron is in a copper sulfate solution, right? If you see iron, if you know the reactivity series, then iron is more reactive than copper. So definitely iron will replace copper from its salt solution. Okay, and what will happen ultimately? Copper sulfate solution is blue initially, but when I dip iron into it, we'll find that the color of the copper sulfate solution has changed from blue to pale green color, and you will find the deposit of copper particles on the iron nail. So this is the explanation of this reaction, and this type of reaction is known as displacement reaction. For this displacement reaction, it is very important for you to know the activities series. So metal displaces a salt if the metal is higher in reactivity series. Okay, so we will take one by one all the reactions. Zinc plus copper sulfate, because zinc is reactive than copper, so copper will be displaced by zinc, and we will get ZnSO4. It is a salt of zinc, and copper will be deposited and in a form of a particle, right? Then aluminum also is more reactive than copper, so copper will be replaced by aluminum. We are getting aluminum salt. Then iron and copper, this we have already discussed, and Pb plus Cu Cl2, we are getting PbCl2 plus Cu. Lead is also more reactive than copper, so copper will be replaced by lead. Next, these are the short answer type questions. 3-marker question. State 3 reasons for the following facts. Sulfur is a non-metal and magnesium is a metal. So you have to give 3 reasons, right? So how can we give the 3 reasons? We should know the properties of metals and non-metals. Okay, now sulfur, is it a good conductor of heat and electricity? No, it is not a good conductor of heat and electricity. Magnesium as a metal, it is a good conductor of heat and electricity. Then sulfur is not malleable nor it is ductile. Okay, magnesium is malleable and ductile. Malleable means it can be beaten into sheet and it can be drawn into wire. This is the quality of ductile, right? Or we say that ductility. Then sulfur reacts with oxygen, gives sulfur dioxide, and when I mix sulfur dioxide with water, I'll get a solution which is acidic in nature. And if I dip, how I'm going to check it? If I dip a blue litmus paper, it will turn into red litmus paper, right? In case of magnesium, this is quite a familiar reaction. Magnesium oxide, magnesium ribbon is burned in presence of oxygen. Magnesium oxide is formed. Mix that magnesium oxide with water. Magnesium hydroxide will be formed. Dip red litmus paper into it. We will find the change in the color. So red will become blue. So we will see that the metals oxides or metal hydroxides are basic in nature. So let's go to the next question. Write the electron dot structure for potassium and chlorine. To draw the electron dot structure, it is very important first to know the atomic number. Once you know the atomic number, potassium atomic number is 19, right? Then write the electronic configuration 2881. Why it is important? Because I want to find out the number of valence electron, right? And once you know the number of valence electron, just put, because it is 1, so you are putting a dot over here, right? And calcium 287, so there should be 7 dots around the calcium. Why? Because there are 7 electrons in the outermost shell. Clear? So potassium and chlorine, potassium will give away 1 electron, so that it will attain a stable state. To attain octet state, so it will give away electron. Chlorine will radially accept the electron. So by accepting it, chlorine will also attain a stable state. Clear? So potassium, when it loses electron, it will become cation. Chlorine adopt electron, accept electron, it will become anion. And here there is a new compound form, that is potassium chloride. So what are the, I show the formation of KCl. So we have shown the formation of KCl by the transfer of electron. Because there is a transfer of electron, give and take relationship, so the bond formed over here is ionic bond, right? Ions you have to name. So potassium ion, this is a cation, and chlorine, this is anion. Coming to the next question, you are given sample of 3 metals, sodium, magnesium and copper. Suggest any 2 activities to arrange them in order of decreasing activity. So let's start. We can we can make them to react with water. Sodium react with cold water, right? And magnesium react with hot water. Copper won't show any reaction in water, right, with water. So this is how we can differentiate and make them in a decreasing order, right? So decreasing order, that means sodium is most reactive, then comes magnesium, and then comes copper. So here we can show other activity also. Magnesium, we will dip magnesium in copper sulfate solution. Copper will be replaced by magnesium, because magnesium in a reactivity series, magnesium is on the top, magnesium most reactive than copper. So the less reactive metal will be replaced by the more reactive element, and we will get the salt of that element. Here we can see that copper is replaced by magnesium. Then if I try to dip copper in magnesium sulfate solution, there is no reaction. Why there is no reaction? Because copper is less reactive than magnesium. So here we can these are the activities on basis of which we can arrange them in order of decreasing activity. Name the following. A metal which is preserved in kerosene. A metal, so definitely you can write any of the metal, that is potassium. We know that there is potassium and sodium, both are the metal. Because they have asked you one metal, you can write one metal. Lustrous colored non-metal, iodine. Iodine is lustrous and it is colored non-metal. A metal which can melt while kept on palm, gallium. And then metal which is poor conductor of heat, that is lead. Okay, gallium and lead. Here in activity series of metal, arrange the metals gold, copper, iron and magnesium in order of their increase in reactivity. So you have to start with the least reactive metal and then you have to go down, right? What will you observe when some zinc pieces are put in a copper sulfate solution? Zinc, because it is more reactive than copper, so you will find that copper is replaced by zinc. Okay, so initially the copper sulfate solution is blue in color, but zinc sulfate solution is colorless, and you will find reddish brown deposits on the zinc, right, on the metal. Some silver pieces are put into green colored ferrous sulfate solution. We know that activity series, so we know that silver is less reactive than iron. So silver won't be able to replace iron from its salt. So here we can see the reaction, silver and iron sulfate, no reaction, because silver is less reactive than iron, right? So the series of metal in which metals are in decreasing order, most least reactive is Au. What is Au? Is gold is least reactive, then comes copper, then comes iron, then comes magnesium, and this is what the answer of this question. Okay, here explain why calcium metals after reacting with water start floating on its surface. Write the chemical equation for the reaction. Name one more metal that start floating after some time when immersed in water. Okay, here calcium start floating because the bubbles of the hydrogen gas stick. Okay, because the calcium gets stick to the bubbles of the hydrogen gas, and when the bubbles comes on the surface, the calcium also starts floating on the surface. The reaction is calcium plus water gives you calcium hydroxide. Remember children, don't write here oxides, it's calcium hydroxides, right? Calcium hydroxide and hydrogen gas is released. Only the iron, zinc and aluminum, in that case you are going to write oxides of that metal, that is aluminum oxide, iron oxide and zinc oxide. Okay, whereas calcium, sodium and potassium, when react with water, they form the respective hydroxide. Now magnesium react with hot water and start floating due to the bubbles of the hydrogen gas stick to it. So other than the calcium, magnesium also floats. Coming to the next question, number 7. Give reason for the following. Aluminum oxide is considered as amphoteric oxide. Ionic bonds conduct electricity in molten state. Why it is amphoteric oxide? Because it reacts like base as well as like acid. Okay, it reacts okay, amphoteric oxide, it reacts with acids as well as base. So in both the cases it will show a neutralization reaction. So this will support that amphoteric is reacting as a base as well as a acid. Okay, and this is because it reacts with base as well as acids to produce salt and water. Salt and water, that means it is a neutralization reaction. Aluminum is less electropositive metal, so it forms amphoteric oxide which react with base as well as with acid. So this is a correct answer that you can write down. Then coming to ionic compounds, definitely can conduct electricity in molten state because they forms ions. So ions are something which are free, they can move freely, so they can easily take charge from one place to another place, and that's why ionic compounds conduct electricity. Yes, next question. You have to balance the equation for the following reaction. Aluminum when heated in air, Al plus O2 gives you Al2O3, and you have to balance this equation. Iron with steam, iron is with steam Fe3O4, it is a reversible reaction. Okay, it is a reversible reaction here, and it is a balance. You have to write it and you have to balance this. Calcium with water, so Ca plus H2O gives calcium hydroxide and hydrogen gas is released. The bubbles of hydrogen gas stick to, hydrogen gas stick to the surface of the metal, that is why it floats. Now next is write balanced chemical equation for the following reactions. So again, dilute sulfuric acid, that is H2SO4, react with aluminum powder, okay, Al, aluminum powder. We are getting aluminum sulfate and hydrogen gases released. Now dilute hydrochloric acid HCl react with sodium carbonate Na2CO3. So remember, carbonates will always release carbon dioxide, water will be formed and salt will be formed. Very important reactions, and after that you have to balance it. Carbon dioxide is passed through lime water. Now what is lime water? That is slaked lime, that is calcium hydroxide and carbon dioxide. What is forming? Calcium carbonate forms, which forms a white precipitate, and due to this white precipitate you find that it is getting milky and water is also formed. So, and then you have to balance the reaction. Next, you have to show on a diagram the transfer of electron between the atoms in the form of MgO. Write a symbol of cation and anion present in magnesium oxide. Magnesium, it has valency 2, electronic configuration or atomic number is 12, so electronic configuration is 282, right? 282, sorry, 282, and and you have to show only valence electron, so that is 2, and that is why we are showing here 2 cross sign. And oxygen, it has 6 valence electron, so 6 electrons are shown over here. Magnesium will try to lose 2 electrons so that it can attain octet state, and oxygen by gaining 2 electron will attain an octet state. So because oxygen is gaining 2 electron which is negatively charged, so we are getting oxides which is anion, and magnesium ion which is a cation. This you have to show. And definitely, because there is give and take reactions of give and take reaction, or we can say that one metal is giving electron and the other non-metal is gaining electron, so ionic bond is formed. Okay, so what about the aqueous solution of ionic bond? Definitely it will carry current. Coming to the MCQs, most reactive metal over here is potassium. Liquid metal at room temperature, mercury. Non-metals are generally liquid, generally gases, generally solids and gases, generally gases and liquid. It's generally solids and gases. The metal which is stored in kerosene, phosphorus, magnesium, sodium. Okay, or okay, magnesium twice they have given, so you can make it manganese. It is sodium. Next, the non-metal which is liquid at room temperature is non-metal which is liquid at room temperature, bromine. Material around us can be classified into elements and compounds, metals and non-metals, bases, acid bases, or none of these, metals and non-metals. All metals are solid except mercury. Okay, then metal oxides are of nature, metal oxide, right? Metal oxide, are they acidic in nature, basic, neutral, or all of this? Metal oxide are usually basic in nature. Let's take the next question. The metal which can cut with a knife, sodium and potassium, barium and calcium, sodium and mercury, potassium and calcium. Of course, this is sodium and potassium. When non-metal react with water, then hydrogen gases form, carbon dioxide is formed, acid is formed. Yes, in some cases acid is formed. So C is the right answer. So this is all about today's topic, children. Practice, work hard for your exam, and thank you.